Hello, this is Akshay with another video here. And this video is going to focus on a numerical problem based upon heating effect of electric current. So let us go through this very numerical problem here. Compute the heat generated. You need to find out the heat generated while transferring 96,000 coulomb of charge in 1 hour. Means when you are transferring charge, then obviously when charge flows through a resistor, the resistance of that very conductor opposes the motion of flow of charge over there. Or in other words, you can say that the flow of electric current is being opposed by the resistance of that very conductor. As a result of this, current needs to do work in order to overcome the resistance. And in order to do the work, current needs to use electrical energy, and the electrical energy which is used by current to overcome the resistance of a given conductor does appear in the form of heat energy. In other words, heat is gonna generated there that heats up the conductor, and that's what the heating effect of electric current is all about. So here, same is here, charge is being transferred in 1 hour under the action of 50 volt potential difference. It is being asked, that is how much heat is gonna be generated during this very transfer of 96,000 of coulomb charge. So this numerical is based upon heating effect of electric current, and let us go through that kind of a, you can say, numerical problem, keeping in mind but we have just driven in heating effect of electric current. Okay, firstly write over here but is given there. So heat generated, we will write down heat generated. This is being asked here and it is H going for question mark. While transferring 96,000 coulomb of charge, this is electric charge or charge, and it is denoted by Q, and it is 96,000 coulomb in 1 hour. It is time T, and it is 1 hour through a potential difference of 50 volt. Here it is potential difference V is equal to 50 volt. Okay, now we are going to find out H here. Remember that is in heating effect of electric current. There are three, you can say, that is representation for the heat produced in a given conductor. One is H is equal to I square RT. That's the one. Second one we have driven in that very, you can say, video, is that H is equal to V square T upon R. And third one is H is equal to V I T. H is equal to VIT. So there are three, you can say, different formulae for finding out the heat produced in a given conductor when the charge flows through it under the action of potential difference. You can use any one of them. Any one of them can be used. This can be used, but for that you need to have I and R. We can calculate I here because Q upon T, it will give you electric current I. Once you got I, you can also have R by using Ohm's law, because V is equal to IR. From here you will get I, and V and I, by using V and I we will get R. So I can be just calculated out here. R can be there. T is already given. We can use this formula as well. We can also use this formula V square T upon R, because voltage is already being provided. Time is given over here. R is needed, and how to find out R I have mentioned over here. And finally VIT. As far as these two formulae are concerned, it needs two steps to reach at the solution. One step is to find out current, another step is to find out resistance. But as far as this formula is concerned, only one step, and thereafter we are very much into the answer. Only one step means voltage is already there, you have got it, 50 volt. Time is given to you, it is 1 hour. And by merely finding out I, we can use this formula straight away. And then we are gonna have the H there. So that's what we are gonna you can say that is use here, because in examination hall it is not the only the solution you are gonna have there, but it is also the time which is of greater importance. So you need to manage the time so that you can just quickly get through this very numerical problem. So we are gonna use this very representation here for heat produced, that is H is equal to VIT. And in order to use this very thing, I is required to be just calculated over here. So that's, I have told you the roadmap, how to proceed further. This is the formula would be put into play here straight away. Okay, before entering into the main description of this numerical problem, let me tell you that is, yes, you need to just have a look at the units there, whether those units are in SI system or not. If not, then you need to put them in SI system. That's first things first. So here time, it is given in hours, rest is okay. Voltage, volt, charge, coulomb, it's quite right, but time is in hours. You need to just transform into second, and you know it very well, it is going to be equal to 3600 second. So there you are. Now time has come to proceed further. Firstly, we are going to find out I, because we know clearly what lies ahead. It is I, which is urgently needed. So that's I is equal to Q upon T. So there you are. Says I is equal to Q upon T. Or I, that is the current, is equal to Q 96,000 coulomb upon 3600 seconds. 0, here it is 0, 0, and it is 12, 3, and it is 80. Coulomb upon second, you know it, coulomb upon second is equal to ampere. Here, therefore, current I is equal to 80 upon 3 ampere. So we have got current I here. Now we are in a position to use this very formula straight away. H is equal to VIT. Here it is. Now we are going to use this very formula here. Okay. As we know that H is equal to VIT. That's the formula. Heat produced is equal to the product of voltage, current, and the time for which the current flows through that very conductor. Or H is equal to, yes, put the value, voltage 50 volt. It is 50 volt multiplied by current I. We have just have it here. 80 upon 3 ampere multiplied by time 3600 second. It is 3600 second. Okay, 50, we are gonna take the units in the backward direction there. 50, 80 upon 3, and it is 3600 volt. It is volt, ampere, it is ampere, and it is second. Okay, now 1, and it's 1200, or H is equal to, it's 50 into 40, 4000 multiplied by 1200, and it is VAS, product of volt, ampere, second is always turned out to be joule. VAS. It's turned out to be joule. And if you are just not knowing this very thing, that how is it happened, then let me tell you one thing. The unit of heat is joule. That's why I am technically using it joule. But still, if someone asks you that is how VAS stands equal to joule, then you should have this very, you can say that is description part, this kind of a question, that is VAS is equal to, volt is equal to, in case of joule, volt is equal to joule upon coulomb. That's what we have learned in the definition of potential difference. Work done upon quantity of charge, and work unit is joule and the charge is coulomb, multiplied by ampere. Unit of ampere, A is equal to, in term of unit, it's coulomb upon second, multiplied by second, it stays second goes away here, coulomb gone, yes, and we are left with only one thing, and that is joule. So that shows VAS, the product of volt, ampere and second, it's always equal to joule, and that's why I have written here joule. Or next, or H is equal to 12,448 joule. Therefore, or you can write it as heat generated. H is equal to, yes, here it is. It is 1000 joules, and you can write it as 4800, and 1000 joules means kilojoule, because 1000 joule is equal to 1 kilojoule. Very simple. 1 kilo stands equal to 1000. So in place of 1000, I have put K here, because 1000 means K, kilo. So it's K, and J is already there. So it has become kilojoule. So either way you can go here. It can be written, or it can be written as heat generated, H is equal to 4800 kilojoule. So that's the amount of heat generated when the charge of 96,000 coulomb is transferred in 1 hour time under the action of potential difference of 50 volt. So that's it here as far as this numerical problem is concerned.